All right, I wanted to go into the adrenal gland. So the adrenal gland sits on top of the kidneys. I look at it. I look at the adrenal gland like a Twinkie, right? So it's got that. It's got a wrapper around it. It's got a cake, and then it's got the creamy filling. So the only difference in this Twinkie is that the cake part of it has like 3 colors, right? So imagine it's like a triple layer: chocolate, vanilla, strawberry, right? Instead of just being one color. So there's a lot of glands that are kind of set up like a Twinkie. And so the wrapper is the capsule, and the cake part is called cortex, and the creamy filling is the medulla. So the adrenal gland is also set up like this. So we're not really going to concern ourselves with the capsule of the adrenal gland, but we are going to discuss the cortex and the medulla. So each layer of that cortex makes a hormone, or a few hormones actually. So, and the medulla makes a hormone, some hormones as well, right? What I have in front of you here, this slide, is talking about the 3 layers of the cortex, right? So, so really what I'm going to focus on, I think for this 15-minute segment, is the first 2. Okay, so that outer layer of the cortex, and then the middle layer of the cortex. So they're called, as you see there, zona glomerulosa, zona fasciculata, zona reticularis. Right, so we're going to focus right now just on the outer 2, and really the outer one, depending on how much time I go through. So I'm really concerned with a hormone called aldosterone. So what you see here is like zona glomerulosa. That's the name of that outer layer of the cortex. So we're talking about the outer layer of the cake and the Twinkie. They make a class of hormones called mineralocorticoids. And so the main mineralocorticoid, the main one that we're going to talk about, is called aldosterone. Aldosterone is set up to, in fact, let me show you. I got a slide here. This is a slide from class that I took a picture of with my phone. You can't really see it too well, but what you can see is this is the capsule out here, and it looks kind of like it's not like single layered. It looks like there's like a few layers here to it. But anyway, this whole thing is the capsule, this darker part, and then right here is the cortex. What you really can't discern in this slide are the different layers, right? But you can see the difference between the medulla and the cortex, right? So that whole thing in the middle here, this is all medulla. And then this is cortex here, and it kind of goes around, and then here's the cortex here, right? You can't see the different layers, but right now I'm talking about this outer layer right there. So this, very important. You need to know it. If I don't ask a question on this, on the next test you have, I'm going to eventually ask you about this, because it's something that you're going to come across later. So it's called Renin-Angiotensin pathway, or Renin-Angiotensin aldosterone pathway, and really it's a body's response to low blood pressure. And so if you could think about antidiuretic hormone, we discussed 2 ways that the body can raise blood pressure. So the whole idea about what I'm going to talk about, aldosterone or the mineralocorticoids, is to keep blood pressure from falling further. So there's 2 ways, there's more, but there's 2 main ways that the body has to do this. Vasoconstriction, and that's what vasopressin does, ADH, it constricts blood vessels. And number 2, conserved water, conserved urine output. And that's what ADH does also, right? So this is similar. We're going to use these 2 ways again. Ultimately, you're going to constrict blood vessels, and you're going to reduce the amount of urine being produced. So how it does it is a lot more complicated, right? So, and I have it right here, and I might just, I'll go with this one first. So let's talk about this one. So what's going to set this whole pathway off? What's the trigger? Dehydration. So low blood pressure, really. So it could be because of dehydration. It could be because of blood loss. It could be things like sodium deficiency, or sometimes when people are on like water pills, like on Lasix or something like that, some kind of diuretic. People with severe diarrhea, people taking laxatives, they could all end up with dehydration, right? So that's going to trigger this whole thing. So it starts off with an enzyme being made by the kidneys called renin. So renin, as it says up here, converts an inactive enzyme called angiotensinogen to angiotensin 1. So look at this long word, angiotensinogen. When you see a word ending with OGEN, that's going to tell you it's a precursor. It's an inactive form of an enzyme. And so what's the enzyme called? You just take off the OGEN. So it's angiotensin. So angiotensinogen is the inactive form of angiotensin, or we could say angiotensin 1, as I put here. So you have angiotensin in your body right now. You have angiotensinogen in your body right now, and you will convert it to angiotensin when renin converts it. So renin converts angiotensinogen to angiotensin 1. Angiotensin 1 is now in your blood, and it's flowing around your body. And somewhere in a few different places, but primarily around your pulmonary capillaries, that angiotensin 1 gets converted to angiotensin 2. And it gets converted to angiotensin 2, as I've written here, by angiotensin converting enzyme. That enzyme converts angiotensin 1 to angiotensin 2. Why are we doing another conversion? Because angiotensin 2 is a very powerful vasoconstrictor. You don't want to constrict your blood vessels if you don't have to. You don't want any false starts. So your body's got like checks, right? It'll convert things more than once just to make sure whatever is happening is something, real. Like, you're not going to throw a blood clot unless you really need to make a blood clot. That's not what your body wants to do. You're not going to start conserving water here and constricting blood vessels unless you're really dehydrated, and it's important to do so. So that's why you have like these two conversions. So angiotensin 1 is getting converted to angiotensin 2 by angiotensin converting enzyme. Right? Angiotensin 2 by itself is already going to raise blood pressure. It's a vasoconstrictor. But angiotensin has another job. Angiotensin 2 is going to go to the zona glomerulosa, the adrenal glands, and it's going to cause the release of aldosterone. So angiotensin 2 is a vasoconstrictor, and it's going to cause the release of aldosterone. So finally we get to aldosterone. What does aldosterone do? It tells your body to hold on to sodium. Because remember, water follows solutes. Examples of solutes are sodium. I just forgot the other word. It's like a very simple word too. Things like sugar, albumin. That's what I was trying to think of. Those are solutes that water follows around, right? So in this case, we're talking about sodium. If you keep sodium, you're going to keep water in your body. If you keep water in your body, you're going to maintain the amount of blood that you have, right? The amount of water in your body is directly related to the amount of blood that you have. And the more blood you have, the higher you can get the pressure, right? So someone that's dehydrated, they actually have a lower blood volume. And that's partly creating the low blood pressure. So you don't want that blood volume to decrease anymore. You want to keep it where it's at, right? So you don't want to use water for urine to produce urine. So this is a little different way of keeping water in the body. It's not like it's not like ADH, like antidiuretic hormone. It's not that the kidneys are just using less water in the production of urine. Here, it's the same thing, but you're doing it through holding on to sodium. So by keeping sodium, you keep water. In fact, some of the diuretics will work like that. It'll encourage your body to excrete sodium. And by excreting sodium, you excrete more water. So somebody with high blood pressure, that's exactly what you would want to happen. But anyway, this is, and so going back to this slide, you can kind of see this is the same thing, just in a longer form, right? So these are the causes of a decreased blood volume, right? So being dehydrated, whatever it is, that means you have less blood. And if you have less blood, you have a decrease in blood pressure. That's going to trigger renin. That starts the whole process off. So that triggers renin. Renin is going to convert angiotensinogen to angiotensin 1. And then we have our second conversion. Angiotensin 1 gets converted to angiotensin 2 by angiotensin converting enzyme. And then they're showing you here that angiotensin 2, it does two things. One, it's a vasoconstrictor. And then if you follow the other arrow, angiotensin 2 goes to the zona glomerulosa, or that's in the adrenal cortex, and it causes aldosterone to be released. And aldosterone is going to cause your body to keep sodium. So when you see the word reabsorption, that means you're keeping it. You're not getting rid of it, right? And then so you just follow it through. And you see at the end of it, increased blood volume, blood pressure increases, right? So that's how it works. So a lot of medications for people with high blood pressure, one of the classes of medications that you've probably heard of are called ACE inhibitors. And so that's right down here, angiotensin converting enzyme. So if you can inhibit angiotensin converting enzyme, ACE inhibitor, you've stopped everything after it. So if we stop the whole process at number 8 here, then you've stopped angiotensin 2, which means there's no vasoconstriction. You've stopped aldosterone, which means there's no sodium retention, right? So you're stopping a natural process that happens in your body. In that case, it's because you have high blood pressure. So you've got, you're choosing between two evils. Do you keep that high blood pressure? You're going to run a little dehydrated. It's better to be a little bit dehydrated than to keep high blood pressure, right? But again, this is a process that's similar to antidiuretic hormone. It's just that your body approaches it a little bit differently. I think I'm going to stop with this one because I'm probably at the 15 minutes.